Hello, this is an introduction to Chapter 1 in Advanced Statistics, and we're just going to be reviewing some key terms in this little video. So we are familiar with what we mean by statistics, but let's just take a review of some of these basic terms. May have been a while. So we can think of statistics as just a way of organizing, displaying, and analyzing numbers. And data really means any kind of information. I mean, it can be words, it can be your address, but when we're talking about stats, usually it's numerical information, or at least information we can turn into numbers. And just for no particular reason, data is actually plural. So it means more than one data point, and datum is actually the Greek word for just one piece of information. And then we talked, of course, in your last class about two branches of statistics, about descriptive statistics, which is just numerical ways of organizing and displaying data about a group of individuals. And if you just do a quick survey, and you're not careful about sampling, you just take answers from anyone who responded, and then you present the answers to whatever people said in a chart or in a slideshow, then that's descriptive statistics. It only pertains to those individuals who responded to your survey. But inferential statistics is what we're working with in this class, and this usually involves some sort of a test. And usually what we're determining are the odds of a particular outcome for a population, and we're basing that on data provided by a sample. So let's look at these two words, population and sample. And so here we have a little fancy stuff I forgot about. So let's look at those words, population and sample. Population is every single individual that you're interested in. So for example, if you're interested in knowing something about Diné College students, then DC College students would be your population. But you probably can't get every single student to answer your question or respond to your survey or whatever it is. So we just take a sample, which is a proportion of those students or a proportion of the population, and we gather our information from them. And there are a number of ways of being able to draw samples so that you can generalize to the population, but you can see here that this guy, is right here, so he became part of the sample. And if they took this sample at random, where every single individual here had an equal chance of being chosen, then we might have the potential to learn about this population from the sample. So in other words, we're going to draw the sample from the population, and then we use statistics. So let's write that here. We draw sample from population. And then we use information from the sample to generalize back to the population. And we'll talk a little bit later about the importance of random sampling if you want to be able to learn about the population from the sample. And that's essential for inferential statistics of a certain type. And we'll also talk later, when we come to t-tests and so forth, about random assignment, which is different. Random sampling, we also say random selection or random sampling. Random assignment is what we can do if we don't have a random sample, but we want to test a certain condition. So this is another way to draw inferences about the population from the sample. And draw inferences, well, that's the root of this word, inferential statistics, which is really at the heart of what we're doing here. Another word that we'll often see is this word generalize. And it just means that we can take this information from this sample and we can draw conclusions about the population in general, or we can infer to the population in general. So these two words have similar meanings. Okay, super important concepts there. So let's go over some key terms that we'll be using a lot: individuals, variables, values, and scores. So individuals are the ones that are providing the data. And so in psychology, these are often people. But they don't have to be people. They could be animals providing data, heart rate data or data about running through a maze or something like that. The individuals could be individual organizations, like colleges, or like certain businesses, or certain franchises of a business. They could be like trees or things in nature. They could be vehicles. All of those things can provide information that we might use to analyze statistically. And what information do they provide? Well, the information that they provide are called variables, and all variables are characteristics of the individuals that can differ or vary among individuals. So as humans, we all have different characteristics. We have different hair color, we have different heights, weights, we have different preferences, different satisfaction levels with certain things, different levels of outgoingness. All of these are variables. So people, just to have these in writing, vary by height. These are just some examples of a million possible examples. We vary by how fast we walk. We vary by our interests. We vary by the number of children we have, and so forth. Organizations can also vary. They can vary by the number of employees they have, or by the gross budget, or by the product type. So all of these things are called variables. The values are all the possible responses for a particular variable. So, for example, the variable height might have values that range from, I don't know what the smallest person would be, smallest adult person, maybe it's 2 feet, and maybe the tallest is 9 feet, but all of the values in between there would be the values for the variable height. The variable favorite color would have values like red, blue, green, yellow, and so forth, and you can see that these are words. And then scores are just an individual's response for a particular variable. So if height is the variable and Jenna is 5 feet 2 inches tall, this would be her score for height. And if color is the variable and Jenna's favorite color is yellow, yellow would be considered her score. We think of scores as numbers. In statistics, yellow would be the equivalent of her score. So let's look at some examples. So some examples here. So imagine that students were asked to rate their satisfaction with the noise level in their living situations from 1 unsatisfied to 5 satisfied. So in this example, the individuals are students. The variable is the noise level in their living situation. The numbers are 1, 2, 3, 4, and 5. Those are the values, I should say. So those are the possible responses that students could choose if it's done in a typical way. And the score, well, for one individual, Carl, he responded 3, so that's his score. Genevieve responded 5, so that's her score. Another example. A biologist is measuring the number of young pinyon pines on a sample of 1/4 acres of land in a given region. So trying to find out if the pinyon pines are recovering or doing well in the current environmental conditions. So in this case, the individuals are 1/4 acres of land. That's where we're counting the pinyon trees. The variable is the number of young pinyon pines. So the variable is right here. The values, well, I don't know, the biologist would find out the smallest, but we could imagine that some of these 1/4 acre plots would have 0, and maybe some would have 200. I don't know what the maximum would be, but the biologist would be finding out. And then the score Well, imagine that all these quarter acres were numbered, and quarter acre 1314 had 42 pinyon pines. That's the score for quarter acre 1314. A couple more examples. So imagine that parents of newborns were asked where they gave birth. And so in this case, the individuals are the parents of newborns. The variable is the location at which they gave birth. The values, well, maybe hospital, birthing center, home, other. There might be other things I don't know about. Otherwise, we can just include them in the other category. And Frida responded hospital, that's her score. And Valerie responded home, that's her score. And the last example, an animal behaviorist measures the number of times cat owners must shake the cat food container before their cats come. So in this case, the individuals are the pet owners, or I should say more specifically, the cat owners. The variable is the number of calls for the cat, so the number of times they shake the cat food container. The values are maybe 1 to 50, there might be more, and in fact, this researcher might have to include a never, maybe the cat never comes. And the score, George's cat came after 3 shakes, Hannah's cat took 15 shakes, those are their respective scores. So at this point, you can go ahead and take that very first practice quiz. This is a review. You will have seen some of these from last term, but it's good to review these key vocabulary concepts.